Now we're going to move on to our properties. Now vectors come with lots and lots of properties, so bear with me. They're probably going to be divided upon many videos, but they're very essential because cases are nothing but remembering these properties and a bit more. But yeah, so what are the properties of vectors? Properties of vectors are things that when you do, they're always going to be the same when you talk about vectors. So before moving on, I might have confused you a bit in the last bit when I was talking about the graph. So let me draw our graphs. As I said, you're going to see it over and over again. Let's start with our first property. Our first property is about the law that's called the triangle law. Now, the triangle law is basically something you need for addition and subtraction of vectors. So we can say we're going to talk about the triangle law, or we're going to talk about addition of vectors. Now let me draw a vector on the graph in order to know what I'm talking about, and in order to clarify what I was doing when I drew the graph. Now we're going to be basically mostly talking about 2D, not 3D, but you always know that 3D is just one letter extra to the 2D, and it's really difficult to draw in 3D, so I'll just ignore it. So yes, here we have our graph, and this is our y-axis, and this is our j-axis. Well, now if we want to do a vector, we said when we say vector, we present it in I and j format. If you remember our vector A, it was 3i plus 2j, and of course our k is 3k, but we're not using it here. We're pretending it's 0. It's just a 2D drawing. So we're gonna go 3 points on the y-axis, and this will be here, and then 2 points on the j-axis, and this will be our point. Now when I say vector A, this is called a position vector, and this is also one of the properties. It's going to appear later. I think it's property 3, but yes, position vectors are property 7, which I'm going to move on to later, but I'm gonna just remind you, then now I'm gonna explain it. So here when we talk about vector A, small a, we're talking about vector OA. So in other words, this here is point A, and our origin is our 0 point. So if we want to draw the vector OA, or vector A, it's going to be this line here, and in the direction O to A, because that's how we wrote it, and the direction arrows as O to A, and this will be our vector A. Now this is our vector OA, and it's also 3, 2, because remember matrix form, and it's very important. Actually, I prefer matrix form when I'm doing calculations, but I like to write it out here that way when I'm just explaining. So yes. Now we have, if we have another vector here that is from O to point B, and this is vector small b, and I tell you that vector B is going to be 2i plus 3j instead, and that means vector OB is 2i plus 2 and 3. Now if I wanted to add these vectors, what do? We do something that's called the triangle rule. Now what is a triangle rule? We want the red, so yes, triangle rule. The triangle rule is basically and simply head to tail. So what is head to tail? It depends on the drawings really. So what I'm going to do here is I'm going to draw our vector A. So it's like this. And then I'm going to go from the head of A, vector A, to the head of to the tail, and start by the tail of vector B, which goes on like this. It's actually longer, but let me just make this shorter. Yeah, here we go. And yeah, so it will be more correct representing, because this is 3, well this is 2, well this is 3. Anyway, so yes, and then what I'm going to do is that we know that this is actually our origin point here, because we started on the graph from O to A, and then we added from A, we added this vector here to get the B here. So what we do is that we draw this point, and then we join this origin to the end arrow here, and then we'll have this new vector, and this new vector will be vector C, which is the addition vector between vector A and vector B. So technically, if we want to write it, we're going to say that C is equal to A plus B, In other words, it's going to be the combination of our i's here and the combination of our j's here. So if we want to say if we want to find c is going to equal to 3 plus 2 into I, and it's going to be 2 plus 3 into j. In other words, it's going to equal to 5i plus 5j. If you want to do this in matrix form, you're going to do the exact same thing and you're going to get the exact same result. So let's do it below it here. If we want to write it, we have vectors c here equals to vector a, which is 3 here, 2 here, plus vector b, which is 2 here, 3 here. What you do is that you add this to this, and you're going to add this to this, which is going to give you the result here, which is 5, 5. So this is actually what your vector c is about. It's 5 units to the right and 5 units to the top. And by this you know how to add vectors and you know what a triangle rule is. Now, if I tell you I'm going to subtract instead, this will take us to our second property, which is the subtraction of vectors. Now, what is subtraction of vectors? I want you to know that subtraction of vectors is nothing less than the addition of negative vectors. So it is equal to addition of negative vectors. So when I tell you I want you to do vector d, which is, let me use another color. Yeah, so if I tell you let's find d, which is not a plus b, but it's a minus b, what I'm saying is that I want vector a added to the negative vector of b. And in here I need you to know that a negative vector, if OB equals to B, then BO is what is equal to negative B. In other words, if I want to draw this here and we drew that our OB is that way, then simply if this is B, then simply our negative vector is going to be the exact same vector here, but in the negative sense, and you're going to have negative B. And if we're going to do that, then we know that we're going from here to here, we're going negative, we're going from here to here. We know that we're going negative on the I, and we're going also negative on the j. So in other words, our BO here is going to equal to, instead of 3i plus 2j, what was it? Instead of 2i plus 3j, it's going to be negative 2i, negative 3j. And if we want to add that, we're going to simply say that vector d is going to equal to 3 over 2, because that's vector a here, and plus our negative vector b, which is negative 2, negative 3. And our resultant vector is going to be 1 and negative 1. And if we want to draw it here, how we got there, we know that our vector a is like this, and then we know that from the head of this to the tail of b, we're going down like this, and okay, we're going down, and then we're going to join from this to this. We're going this way, we're going exactly 1 down and 1 to the right. Of course, here it's I plus I, and here it's negative j. And of course, this is not an accurate drawing, but it gives you an actual representation of it. And that will be our second property, the subtraction of vectors, or the addition of negative vectors.